Hi, my name is Mel, and the following presentation will offer a thorough introduction and exploration of subnetting with both IPv4 and IPv6 addressing. We will cover fundamental concepts, practical techniques, and applications to help you understand and efficiently manage IP networks. Our session will begin with an overview of IP addressing, followed by a deep dive into IPv fundamentals and subnetting concepts. Then we will explore IPv6 addressing and subnetting differences. Finally, we'll examine practical applications and tools for subnetting. Understanding IP addressing is critical for networking. The following section explains the purpose of IP addresses and gives an overview of IPv4 and IPv6 formats, laying the foundation for subnetting concepts. IP addresses, or Internet Protocol, if you must know, unique addresses uniquely identified devices on a network. So no two IP addresses can be the same, okay? Enabling communication and routing of data packets, all right? They serve as the essential addressing scheme for all internet-connected devices, all right? So an IP address, you can type in HTTPS, colon / www dot, or you could just type in, whatever the internet, like Google is 8.8.8.8. Okay, that's their address. So I think it's IP addresses help identify devices that can connect to the network, all right, internet specifically. Okay, so IPv4 addresses use a 32-bit numeric format divided into 4 octets. It's divided into 4 lots of 8, typically represented in decimal form. Okay, this section covers the structure and representation of IPv4 addresses. IPv6 addresses are 128-bit hexadecimal numbers designed to overcome IPv limitations. And IPv limitations were that we ran out of internet addresses quite a while ago, because so many devices now are online that we had to go up to IPv6, which is 128 hexadecimal, which means it's 0 to 9, A, B, C, D, E, F. All right, hexadecimal. So that's how it addresses, designed to overcome the limitations, which IPv was just running out of addresses, right? And also IPv6 is more secure in general and better to use, easier to set up. The transition, however, has been a bit slow, but really everything needs to transition eventually, probably over to IPv6. Okay, so this highlights the format and notation used in IPv6 addressing. So in IPv6 addressing, you will see, A, E, B, C, D, F in the addressing format because it's a hexadecimal number, okay? So in IPv4, you'll only see 0 to 9 digits, but in IPv6, you will see 0 to 9 and A through to F, right? Just so that, that's IPv6 addresses consist of network prefix and interface identifiers, okay, for routing and identification. Dive into the structure and classes of IPv4 addresses, including distinctions between public and private addresses and special address types used for network functions. IPv addresses are categorized into classes A, B, C, D, and E based on the leading bits and address range, okay? This classification helps organize networks and allocate addresses efficiently. And I'm going to go through this in another video a bit more, but I'm just going through like subnetting here. Okay, but like how this works, you have like a certain address range and how many bits that you give to the host to give to the rest to the clients will decide, like in that sort of thing, how many addresses you've got. All right. Public IPv4 addresses are globally routable on the internet, while private addresses are reserved for internal use only within networks. Understanding the difference is vital for network design. Okay, so within like a public facing IPv address, right, that will have private addresses. So it'll be like usually 10 dot something is a private address. There are others as well. And then you can decide, like, is it going to be 256? How many, like, if you're going to subnet 256, you know, /256 or something like that. But we'll go into that elsewhere as well. Certain IPv4 addresses have special purposes: loopback for testing and broadcast for sending to all hosts, and multicast for group communication. These play important roles in network operations. Yes, so when you're assigning, so if you're going to say like 128 or something, you've got to at least have two addresses reserved at least for loopback and broadcast, okay? And if multicast, that as well. It's depending on how you set this up. So we'll go into this as well. Subnetting breaks a larger IP network into smaller, manageable subnetworks. This section explains why subnetting is needed, introduces subnet masks and CIDR notation, and demonstrates calculation formulas. Okay. Subnetting partitions IP networks to improve routing efficiency, enhance security, and optimize address utilization. And this is sort of like you might have, 100 people in one department and 50 in another and 200 in another. And you might even have sub-departments. You can also say these people in this department just do this function. So even a department that's got like large numbers, you can sub-route and you can do subnetting in there so that so people are not crossing over. It's much more secure and optimizes address. And it allows organizations to create multiple logical, so we're not talking physical, logical networks within a single IP range. Yep. And also, like, subnetting also helps, like, so if traffic, like, it helps with traffic and addressing, because if you've got, like, a lot of people in an area, you do not want too much traffic. So, like, any more than, say, like, I wouldn't go over certainly 100, but you could have, I guess. But like you want traffic and addressing to be better. Subnet masks define which portion of an IP address is the network and which is the host. Yeah. So that's what I was trying to explain before very poorly. So the number of bits at the beginning will say this is part of the network, or this, like, and this is part of the host, as in this is the private thing that's us. All right. CIDR notation simplifies subnet representation using a suffix indicating the length of the network prefix. Okay. And we will talk through all of these issues elsewhere, but this is just a basic overview. And I know a lot of technical terms have been thrown at you right now, but it's important that you at least understand why this occurs, okay, and sort of how. Subnet calculation involves using powers of 2 because, you know, like that has to determine the number of subnets and hosts. Practical examples illustrate how to derive subnet counts and host capabilities or capacities. Okay. This section breaks down the subnetting process into clear steps, including identifying network and host bits, subnet creation, and determining usage, host range, and broadcast addresses. This is for IPv4, okay? Identify which bits in an IP address represent the network versus a host by applying the subnet mask. This distinction is fundamental to subnetting and proper address allocation. Subnet creation requires planning the number of needed subnets and hosts, then adjusting masks and IP ranges accordingly to meet organizational requirements. Okay, and if addresses overlap, you're going to have a huge problem here, so you want to be careful. So this is where you sort of plan it out on paper, I would think, first, and make sure. Okay, so this is, yeah. So if you say /128, that's what I mean, or /256 or whatever, or /64. Calculating the range of usable IP addresses within a subnet and identifying the broadcast address ensures proper communication and network functionality. Yes, for sure. Explore practical subnetting examples using Class C, B, and A address ranges to understand how subnetting works differently depending on network class size. Because Class D and E use sort of like specific functions usually, although there's classless now and everything else, so yeah. Class C networks, typically used for small networks, have a default mask of 255.255.255.0. So what this denotes is that the first, this 255, this 255, this 255 are all network. It's only this bit here that is for the host. So at maximum, you've got 256, but you have to give 2 for broadcast and loopback, okay? So this is what's like what they're talking about the mask here, okay? It's a 255.255.255.0, okay? This slide demonstrates subnetting techniques for creating multiple subnets within the Class C ranges. Okay, and this would be your smallest. This would be like for very small. Like you can have like, you know, people of 8 or 16, 32, people 4 even, I guess, if you technically want that. Although you'd probably only get 2, but anyway. Class B networks are medium-sized, use a default mask of 255.255.0.0. Okay, so you can see here the 255.255, they are the network portions. So the .0.0 are the host. Okay, so this, you have more address ranges to the host in this Class B network, right? Learning how to subnet these networks efficiently for an optimized address distribution. Okay. Class A networks are 255. These are large networks with a default mask of 255.0.0.0. This section covers subnetting strategies for extensive and complex network environments. Okay, so again, I'm saying the 255 here is the network and the .0.0.0 is the host. And you'd have to bet 65,000 roughly available addresses for this. Okay, so this would be a very large and network with complex, and you could subnet here in here too. Delve into advanced subnetting methods using variable length subnet masking, or VLSM, to enhance address utilization and considerations for enterprise network environments. VLSM, or variable length subnet masking, allows for subnets of different sizes within the same network, enabling more flexible and efficient use of address space based on specific needs. And certainly that is preferable. But again, this is all IPv4. Just want to mention that. I think sort of like a lot of the solution for this is IPv6, but again, look, that can be expensive to transition. You need to know have people who know how to do it. But I think the solution will be to go to IPv6 for a lot of people. But yeah, this is an option. Optimizing subnet sizes help reduce IP address wastage and improves network performance. And that's certainly, like if you've got like a non-VLSM that's like /128, but you've got like 90 people there, that's you're wasting address ranges, okay? You just are. So it improves network performance. Strategies focusing on fitting subnet sizes to actual requirements. Yep. Large organizations require careful subnetting planning to manage complex networks, ensuring scalability, security, and efficient routing within their infrastructures. Okay? And you can see a firewall here. You certainly would have firewalls between all of this stuff, and you'd have routers and switches and stuff like that. You'd have to. Okay, that's sort of how you do that. IPv6 introduces a new addressing system to meet growing internet demands. Well, yeah, and it's more secure and easier to use. This section explains its structure, types, and notation methods. IPv6 addresses comprise 128 bits, which has got like about a couple of quintillion or something available addresses, more than we should need for a while, into 8. So this is divided into 8 16-bit blocks. So instead of divided into octets like that was 4 by 8, this is 8 by 16. So this is 8 16-bit, or hextets I think sometimes they're called, I don't know. Include components such as global routing prefixes, subnet IDs, and interface identifiers. Okay, so IPv6 is more efficient easily, and it's better because much more range available. IPv6 supports unicast for single interfaces, multicast for groups, and anycast for the nearest of multiple interfaces. These types enable versatile communication models. IPv6 notation uses hexadecimal digits, so again that is 0 to 9, A through to F. Separated by colons with rules for abbreviation like omitting leading zeros and collapsing consecutive zeros to simplify representation, and they certainly do that. So sometimes you'll see double colons because they've omitted a whole lot of zeros, all right? Or the front of it won't be there because it's leading zeros, okay? So you need to remember that about IPv6. Okay, so instead of a dot or a full stop like with IPv4, this uses a colons. Okay, so that's a difference, you'll know, and you'll see letters in this as well. Subnetting in IPv6 differs from IPv4. This section covers prefix length, subnet allocation, and how network identification is structured. The prefix length in IPv6 indicates the number of bits representing the network portion of the address, which is critical for routing and subnetting. IPv6 subnetting uses larger address spaces and simpler subnetting rules. Unlike IPv4, subnetting focuses on the subnet ID field, which I think means identity from memory, within the address structure. IPv6 subnet allocation involves dividing the address space into subnets, typically on a /64 boundary, supporting vast numbers of hosts per subnet. Yep, certainly does. Learn how to divide IPv6 address space, calculate subnet boundaries, and work through examples illustrating practical IPv6 subnetting. IPv6 address blocks are divided by adjusting prefix length to create subnetting, allowing flexibility and enormous address capacity for networks. Determine the range of addresses in each IPv6 subnet by applying prefix length calculations and understanding hexadecimal address increments. Real-world examples demonstrate how to subnet IPv6 addresses effectively, illustrating prefix assignments and subnet ranges. Explore tools and real-world applications that assist with subnetting tasks and troubleshooting, enhancing network design and management. Subnet calculations simplify the process of subnetting by automating calculations, supporting both IPv4 and IPv6 networks for accurate planning. Yeah, and you can get a lot of tools, free tools for this, to do this, so you're not sitting there trying to work out all the math, because you do your head in that way. So get the tools, use them. Subnetting is applied in various real environments such as corporate networks, data centers, and internet service providers to optimize network performance and managers. In fact, pretty much every company that has a network would have some kind of subnetting. They really would, because it's just much more efficient, much more secure. Okay. Common subnetting problems include misconfigurations and address conflicts. Yeah, again, if your IP addresses are overlapping, you are going to have a problem. This section covers strategies and tools to diagnose and resolve subnetting challenges. Yep. Understanding subnetting for IPv4 and IPv6 is essential for efficient network design and management. Applying these concepts and tools will improve address utilization, scalability, and network performance. And look, we went over things very, very briefly. I want to go things into more in depth in another video, all right? But this is just so you know some of the terminology and some of the concepts. And obviously we skipped through an enormous amount there, and we didn't really go through how you would, what tools you would do or anything like that, but we will do that in other videos. Thank you for your time.